Colonisation of hard surfaces needs bare hard surfaces. Return of a thin layer of mobile sediment removes species which cannot tolerate scour or blanketing. Blanketing is the removal of access to the water column by a layer of sediment for feeding or respiration, and also the removal of light for photosynthesis. This video does not look at sediment in fauna, but at epibiota on hard surfaces. Different species show different sensitivity to sediment settling. Some are highly tolerant, some appear to be specialists, and there may even be a list of indicators analogous to ancient woodland indicator of vascular plants and tree species in terrestrial ecology. Different sediments operate in different ways. Fine silt, as seen here, tends not to scour very much, but is very blanketing, even when the layer is very thin. Biogenic fragments often mix with silt. They're lighter, more easily lofted, and settle slower than geogenic fragments, i.e. small pieces of rock, sand in inverted commas. This video looks at sediment tolerant species, the circalittoral and sediments. Here we see a site called Beer Fans in Lyme Bay, 24 metres below sea level, and we've got a silt veneer on flat rock, which is probably calcareous sedimented fine sandstone. Community is dominated by papillate sponge cushions, as you see here, Polymastias. You can also see dead men's fingers on this site, and the sponge to the right is Polymaster Oblitiformis, and in this still we've got Polymasty penicilis and some closed papillae Polymastias of unknown species. Here's a close-up. See Polymasty penicilis on the left and a closed papilla species on the right, and intermediate forms in the centre. Close-up of some other species on the same site. Look at the one at the top left, 11 o'clock. Closed short papillae, sort of peachy colour. This may be Polymastia agglutinans. You can also see on the right here the twin siphons of Rossulari Dubia. This is the same video, giving a little more context. And you can see a whole variety of different Polymastias. This community is dominated by Polymastias, some of which may be sediment veneer specialists. Bit more of a waft, which exposes another Polymastia species. This is from another site called Lulworth Banks. It's about 23 metres below sea level, and this is biogenic fragments with silt, so a different sediment. And we've got a closed papilla Polymastia, and this is again probably Polymastia agglutinans. You can see sediment particles adhering strongly to the cushion. This is Lulworth Banks East, again 23 metres below sea level. On the left you can see a Polymasty Oblitiformis. These seem to have taller cushions, this species, which raise the top of the cushion and the papillae above the level of the sediment. But here this sponge gets submerged from time to time by this highly mobile sediment, which is biogenic fragments. This is a close-up of the same sponge with the sediment wafted away. The pink arrows are coralline crusts, which are highly tolerant of sediment veneers, even in fairly deep water. Black arrows are erect bryozoans. The orange arrow is a sponge crust, very small. You can also see barnacle, dead barnacles and barnacle scars. There are also some worm tubes here. This is a fairly simple veneer biotope. You can also see that the sediment is fairly deep, very mobile. This is the sediment close up with a DSLR camera, and you can see, although there are some shell fragments here, a lot of the sediment is other biogenic fragments, including pieces of barnacle carapace and segments or joints of erect bryozoans and pieces of pentapora. This shot shows sponges on the same site in a thinner veneer. Number 1 is Polymastia penicillis. Number 2 is Circalittoral penicillis. Number 3 is Adreus fascicularis, which seems to be a bit of a specialist on veneer habitats. And on the left, number 4 is Rossulari Dubia, which can be confused with Adreus fascicularis. Adreus is supposed to be rare, but is actually fairly common, frequent in Lyme Bay and Dorset coast veneer habitats. Next shot is the same species with the ID characters, which are the pointy ends to the branches and vertical striations. This is from another site called Sponge Canyon off of Swanage, 25 metres below sea level. It's quite open and strong tidal streams, rugged topography, lots of sand, geogenic fragments in this case. This is possibly again Polymasty Oblitiformis, as you can see the peachy colour, small curved closed papillae, and this slightly peachy colour. Particles adhere strongly to the cushion of the sponge after a stiff waft, and you can see another closed papillae Polymastia to the right, exposed by the wafting. And this is another closed papilla Polymastia, species unknown. There are several species unknown on this particular site, which is very rugged topography. A lot of sand, which is in some places in deep drifts and in other places slightly raised. It forms veneers of varying depth, very scour producing, as the particles themselves are fairly dense and fairly rounded. They settle quickly out of the water column. This is the same species after a waft, and you can see also on the right a coralline crust, albeit small. This is Adreus fascicularis from the same site with Flustrifoliacea. The Adreus here tends to be smaller and very more densely branched, so it seems to be showing environmental plasticity. On these core sediment sites it seems to be more like this than the taller, less robust form on silt. This is a graphic, and basically from observations in Lyme Bay and Dorset indicates the possible relationship between typical energy of a site, depth and sediment likely to be found. Note this is biased. This is dived observations. Dived observations of course are only possible in slack water and good weather. Sites may look very different in winter or when storms and big tides coincide. This video is from West Tennant's Reef in Lyme Bay, Devon, and at 27 metres below sea level. This is Pink Sea Fan Park, and you can see here that there are a lot of very small first year pink sea fans and some other young pink sea fans, and you've got a silt veneer on flat rock, and you see a lot of Polymastia species. You can also see Stolonica socialis, which tends to be seen early in the year, regressing and overwintering starting from August onwards. Also Alcyonidium diaphanum, and Rossulari Dubia is here, and Rossulari Dubia plus Adreus fascicularis, but on this site it's rare and it can be confused with Rossulari Dubia. This is moving in to look at a Polymastia, and in a moment there will be wafting. This is to look at the sediment depth and consistency, and you can also see here that on most of these Polymastias there's very little contraction on disturbance or wafting, so the papillae, if they are open, remain open after a waft. you can see again this is a large area of similar habitat. Some of the pink sea fans are on slightly raised areas, but pink sea fans in general seem to be highly tolerant of sediment veneers, although you can also find them on clean raised reef. This is a still from the beer fans one site we saw at the start of this video. This is silt veneer, and you've got dead man's fingers. The arrows that pop up show solitary squirt top right on a small pebble, so raised. Below it at about 5 o'clock are ginger tinies, small anemones, seem to be very tolerant of sediment veneers. On the top left you can see 2 species, possibly of Polymastia, and in the centre, the white arrow pointing upwards, is Rossulari Dubia, which you can also find on reef surrounded by other species, but seems to be highly tolerant of sediment, especially silt veneers, on the correct type of rock, i.e. calcareous rock or calcareous sedimented sandstones. The black arrows are sediment species which can appear even in very thin veneers, such on this site, where the toes are in pockets of sediment. In this case they are in bivalve bores. Top one is a sandmason worm, the bottom one is Ceranthus lloydii. So, summary. Sites chosen all have flat substrata. Where substrata are more diverse profile, veneers may be of more than one type, for example silt on flat surfaces, in fine calm weather, especially in summer, and these may settle out of the water column over fairly long periods of calm weather, and are composed of bacteria plus plankton material from the water column plus very fine sediment. On deeper hollows you may get silt and biogenic fragments, especially where they're in current shelter. And in hollows you may get deeper sediment or mud. On these sites you get a mosaic of habitats with veneer influences, and these can be complicated to record. Unfortunately, time and on-site and the ability to revisit to do quadrat-based recording and statistical analyses of communities in these deeper sites has not yet been available. This is a work in progress, based on diver observations, and comments are welcome. A part 2 is planned, which will look at infilitral algal dominated sites.